Some common applications of solving systems are using information about perimeter. So we're going to look at two separate examples dealing with perimeter systems of equations. The first says the sum of the length and width of a rectangle is 21. So that's the first sentence in our system, and I'm going to be translating that in just a minute. The next says the length is. Again, this is going to indicate whatever variable I use for the length, and is always means our equal sign. Again, this is going to be 3 less than twice the width. And I want to find the length and width of the rectangle. So when I'm trying to find the length and the width of the rectangle, I can use any values or any variables, that I want to indicate length and width. So I'm going to use an uppercase L when I'm talking about the length, and an uppercase W when I'm talking about the width. Right? So it doesn't do me any good to use X and Y if I can use two other variables that could represent the information a little bit better. So this first sentence, the sum of the length and width is 21. So again, some of our keywords, sum, I'm going to have to add the length and width together, and that value is going to equal to 21. So let's start setting up our system. And so length plus width is 21, and that gives us the sum of the length and width is 21. Now the next part to our system, the next sentence says the length is, again there's another keyword, 3 less than twice the width. And so again I'm going to translate that. The length is 3 less than twice the width. And so sometimes when you're dealing with less than and more than, it's a little bit easier to write the plus or minus first and then translate what's happening on the left. And this is going to be using the substitution method. And again, that's because it already says an expression for L. Then I can substitute. And so we have 2L minus 3, 2W minus 3 being substituted for L, plus W equals 21. And so this was my substitution. And now again, I can combine my like terms. And so I get 3W equals 24, or W equals 8. And my length plus my width is 21, so L is 13. And I'm going to write my information as length is 13, width is 8. All right. So it's good to go back and use the words for the variables instead of just L and W, actually indicate length and width. That way if you choose to use variables like an X or a Y, that people know exactly which one is which. So this is one type of translating where you are given information about the length and the width, where you don't need to necessarily know what the formula for a rectangle is, because you're just talking about general information about the rectangle. So another type of example dealing with rectangles is where we will actually need perimeter formulas. So for example, we have that the perimeter of a rectangle is 50. The width is 4 more than the half the length. And I want to find the width and length. So again, I'm going to use values or variables W and L. And so when I translate my system, the first one says the perimeter of a rectangle is 50. Right? So in my system, I need to think about what a rectangle looks like. All right, in a rectangle, if this is considered the length of the rectangle, this is also the length, a width and a width. So the perimeter means I'm going to walk all the way around and add up all of the sides. And in this case, that means that I have 2W plus 2L, or 2L plus 2W equals 50. Right. So 2L plus 2W is 50. That's saying the perimeter is equal to 50. And now I'm saying the width is, and here's another one of those keywords, 4 more than. So my width is 4 more than half of the length. And so this is my translation of my system. Again, I already can use substitution on this because I have an expression for W that I can plug in. So 2L plus 2 times the 1/2 L, oops, got my parentheses, plus 4 is 50. Be careful, I almost forgot my parentheses here, and if I had forgotten my parentheses, I would have completely forgotten that I need to distribute to this 4. So we want to make sure that everything that we are expressing for W gets plugged in for W. And then in that case, I have 2L plus, when I distribute, the 2 and the 2 are going to cancel out, and I get 1L plus 8 equals 50. Right. And so in this case, I will end up with a 3L equals 42, or L equals 14. And then I can plug that back in. I'm going to plug it back in for this expression where W is 1/2 of the L plus 4. And that's going to give me the value of 11. So again, the values I need are when the width equals 11 and the length equals 14. And those are the values that would make the system true.